Okay, we are on the afternoon of January the 12th, and what we're going to start doing is looking at curved mirrors. Now, curved mirrors are based on a full circle. If we took this full circle and we only took this portion here and turned this into a mirror, what we would have is a concave mirror. And the best way to remember this is it looks like you're going into a cave. So it looks like you're going into a cave. Now, if we took this circle and we found the center, this would be called the center of curvature right here. If we took this, excuse me for 1 second. If we took this, we took the distance from the center of curvature to the mirror and we half that, that's the focal point. So if it's 5 centimeters from here to here, it's 2.5 centimeters to here, that's the focal point. Now the focal point is important because if we shine rays of light parallel to the principal axis, this here is what we call the principal axis, and they hit this mirror, we know that light is going to reflect back through the focal point. So the light will reflect back through the focal point. Now remember, as you go through these videos, you should be taking some notes. I would be labeling this as the principal axis, center of curvature, focal point. Some people use short forms like this. And remember, one of the advantages to having video is you can always go back and replay it. So once again, concave mirror, it's shaped like this. It's got all sorts of uses in technology. One idea here is solar energy. It concentrates the light. All the light would be concentrated right here. We have two important points on here. We've got the focal point and center of curvature, and we know if we direct a ray of light straight at the mirror, it will come back through the focal point if that light ray is parallel to the principal axis. Now, we have 4 laws that you need to know. And what we're going to be doing is we're going to be drawing diagrams this aft. The first law is if you direct a light ray parallel to the principal axis, the light will hit the mirror and reflect through the focal point. Law number 1. I can call it law number 1 or drawing number 1. Line parallel to the principal axis, once it hits the mirror, goes through the focal point. Number 2 is the opposite of that. If you line up the focal point in the mirror and you draw a light ray directly at it, the light ray will come back parallel to the principal axis, like that. This is the second line you need to be able to draw. I would highly suggest that you have pictures of these in front of you when you do today's drawings. Drawing number 3. If a light ray goes through the center of curvature, it hits the mirror and it comes back on itself. So if you draw a line through the center of curvature, it hits the mirror and it comes back on itself. This is true in all concave mirrors. Here comes our last law, and then we'll try some drawings. Our last law is not used all the time. Some students like it. I don't use this one very much because it's a little more involved. If you draw a light ray at the point where the principal axis strikes the mirror, and let's say you measure that and it's 10 degrees, that means the light ray will reflect off at the exact same angle. Now, when we're doing our drawings today, this only works if you measure with a protractor and get this exact. If you do not, it won't work. So let's take a look at what we're doing today. We'll do 3 examples. What you're doing are drawings in curved mirrors. So what you have is an object. So if you imagine that this is a person standing here. We'll use an arrow as an object, but if you imagine it's a person, this would be its feet on the ground. This would be the person's head right here. And if you wanted to know what that person looked like if they looked in this mirror, you have to draw at least 2 of those lines. So let's give this a go. My first line will be a line parallel to the principal axis, and then straight back through the mirror. The second line I'm going to draw is the one that goes from the top of the object through the focal point, hits the mirror, and now comes straight back parallel to the principal axis. Wherever these 2 lines cross, after they've reflected off the mirror, that's where the image is going to be. So there's the feet, they're on the principal axis, so the feet here have to be on the principal axis. The light coming off of the head of the object, wherever that light crosses, that's where the head is. So we could have drawn this to look like a person if we wanted to. What does this mean? Well, size-wise, they look to be about the same. So what that means is the image is the same size as the object. Attitude, this guy's upside down. So if you look at yourself in one of these concave mirrors, this is really cool, and we do this in class when we have the apparatus. This person is upside down. Location, in front of mirror. Now, this is the one that everybody has trouble with and type, because the light rays are actually forming right here. This is a real image. In other words, if we put a screen here, we could pick up that image on the screen. Before, when we did plane mirrors, the image was in behind and we used dotted lines. Whenever we use dotted lines, that means our image is virtual. So if you see real lines, that's a real image. If the lines are imaginary back behind the mirror, then that is virtual. So same size, upside down, in front of mirror, and real. Let's try a couple more drawings. I'm going to choose to go, I'll choose one of my 4 lines. I'll go from the top of the head, down through the focal point, and straight back. Here's another one. I can go from the top of the head through the center of curvature. Now I'm going to have to extend the mirror here to make this work. That's another one of the lines that we've talked about. Here's another one of the lines that we talked about. Now I only need 2. Now, all 3 are crossing right there. Remember, you only need 2. I use the top of the head through center of curvature rule. I use the top of the head through the focal point, hits the mirror and comes straight back rule. And I use the parallel to the principal axis and through the focal point rule. You might have to watch the video several times to get this. There's my image. So if you're standing between the focal point and center of curvature and you look in a curved mirror, you are going to be larger. So the image is larger than the object. So remember, this is a person sitting there, and this is what their image would look like in the mirror. Attitude, upside down. Location, in front of mirror. Type, it is real. Okay, let's do one more. If you were right on the focal point, you cannot draw from the tip down through and hit the mirror. It will not happen. You can go straight across to the mirror. You can go from the top of the arrow through the center of curvature. And if you've drawn this properly, what you'll see is these lines never meet. And what that means is if you stand at the focal point and you look in a concave mirror, you will not see yourself. Once again, this is something we do when we are in class. If you stand at the focal point and you look in this mirror, you will see nothing, because these lines never meet, and we don't get an image if these lines don't meet.